story begins in the back of a pickup truck. It's 44 degrees outside and my t-shirt is soaked in sweat. Outside the window, there's only red dust and nothing else. I grab my water bottle and wash away the spicy taste of African soil. I finish the bottle, we'll be home soon, is what I'm thinking, when the engine suddenly stops. Steam is pushing out from underneath the bonnet, and Nelson, who's a local, turns around at us and smiles his widest smile. Shit, do you have any water? So we climb out of the truck, and there we are in a half circle around the steaming car. A bunch of scientists in ridiculous khaki functional wear. Whoa. With our cheeks burned and half-empty water bottles. We pour the last cups of water onto the motor, and with a long hiss, it tells us that our effort was a joke. And what can I tell you? We didn't get the car to work, and the sun kept beaming down on us. We had to walk quite a long way, and we all got very, very thirsty. Sorry. After miles of walking, we finally reach a little farm. Lush avocado trees and banana palms, flowering vines open up in front of us, and it's like a little oasis. Without a second thought, we all sprint to the next tree and drop down underneath the shade. So I come from a family of farmers and a village of 1,000 cows and half the amount of inhabitants. I think it's actually 300, to be honest. Before going to Tanzania, I had gained quite a bit of experience. But in this very moment, standing amidst the fertile mixture of red African soil and a lot of cow shit and chickens rummaging around everywhere in the leaf litter, I actually realized that my little trauma with running out of shade and water was everyday life for millions of people around the globe. And that a little piece of land, of arable and well-managed land, can make all the difference. And this is where my scientific journey began. Now, like Monica said, I did my master thesis on ecosystem services of birds and bats in coffee plantations on Mount Kilimanjaro. And I wanted to see whether the intensification of coffee farms results in a decrease of this pest predation service by birds and bats. And here's a photo of the natural plantation system on Mount Kilimanjaro. It's really beautiful. It's called Chaga Home Garden, and the system is over 2,000 years old. And sometimes it's so elaborate, the water system, that sometimes it looks like the water is flowing uphill. And yeah, it's just amazing how they created this. And it's been used as an example for successful agroforestry and permaculture multiple times. So you can see all these vegetation layers. The big trees, can you see this cursor? No, okay. The big trees, the canopy is built up out of avocado trees and mango trees and natives that are used for building and firewood. And underneath you have the banana palms and coffee plantation. And the lowest vegetation layer is herbs and vegetables and vines that they use for medicine and as leafy greens. And these farmers sell the typical cash crops such as coffee and bananas and live off the rest of the land. And often they have a handful of cattle that also fertilizes the plantation, and they eat the meat and drink the milk from these animals. And the coffee from these home gardens is usually sold through fair trade alliances. So when you go and buy the Highland coffee or fair trade coffee, it's usually this coffee. Yeah, and no wonder that the bird and bat life is very abundant and diverse. And then the second step, you can see it's quite a bit more simple, right? Not as beautifully like overgrown and lush. And this is a shaded plantation where you see vegetation is mostly cut down and you only have a few shading trees, and the rest is all coffee. And it's like grown in rows so the tractors can go through. This is a lot more simple, and hence the bird and bat life is less impressive than the previous plantation. And the owners are predominantly international investors, and people that work there are locals, but they're usually employed for maintenance or harvesting. And then the most intensified coffee growing system, that's where we usually get our coffee from at uni, or the instant stuff that I sometimes have in my shelf. And yeah, this is the most intense way to grow coffee. These are breed varieties that can survive in the sun, because usually coffee is grown in half shade, but when you breed it that way, then you can have it in the full sun. And so you see that there's no other vegetation apart from coffee. So no shading trees, no, I don't know, not even grass on the ground. And obviously that's not very inviting for birds and bats and pollinators, one could assume. Yeah, and the owners of these plantations are international investors and often very big companies. And the locals are dropped off by buses to pick coffee berries. And often I observed that people kept picking while the plants were actually sprayed with pesticides. And that was the experiment. I excluded birds and bats from coffee plants with these mesh cages that were usually, or like every 2 months or so, they were eaten by termites. We have to go back and replace those sticks. And, yeah. And they remained on the plant for 6 months. Before and after the 6 months, I sampled the arthropod communities and assessed herbivory damage. And my colleagues, they added a pollination exclosure similar to what we did in our group with these little mesh bags to test for the effect of land use on ecosystem service of pollination. Yeah, the study included 12 plantations, and there were 3 sets of these different treatments. So you can see the open control where birds and pollinators had access. And the second one from the left is where the bees, the pollinators were excluded with these mesh bags. And the third one is where only birds and bats were excluded. And the fourth one was a full exclosure, you know. Yep. So then let me guide you through the results of the study. Here we're looking at the combined effects of the exclosure of pest predators and pollinators on coffee fruit set in the top panel and fruit weight in the bottom panel. And these 2 parameters are very important economic factors, right? Like how many fruit you get and how heavy your fruit is important. So yeah, on the x-axis you can see the 4 different treatments, so open control and so on. And they are grouped per plantation type. On the left, you have the home gardens, the most natural plantation. In the middle, you have the shaded one. And on the right, the most intensified sun plantation. And for fruit sets, so the top panel, we can see that the exclosure of birds and bats, which are the 2 light gray bars on the right side each, they're lower than when birds could access the plant, right? So it says that in the presence of birds and bats, we had a higher fruit set. Pretty good, no? If you're a farmer and you have birds and bats for free and you have more fruit. And then in the bottom panel, we can see that for the fruit weight, if you had the pollinators around, like you can see that when the pollinators were excluded, the gray bars, the light gray bars, they are lower than the dark gray bars. So when the pollinators were there, and that means when you have pollinating insects, then you have a higher fruit weight. And so the conclusion of this collaboration is that the complementary ecosystem services of pest predators, birds and bats, and pollinators leads to or increases the quantity and quality of coffee yields. And I think it's yeah, I'm still very happy about this result because it's such an important cash crop. We all drink quite a lot of coffee, right? So yeah. The results were published in 2014 and then later on in a meta-analysis by Dainese et al. In 2019. And the overall analysis found that biodiversity increases crop production. But to me personally, this social aspect of the plantations was just as interesting as the ecological aspect. And yeah, as I said in the beginning, the home garden owners were actually self-sufficient local farmers that took pride in their land and yeah, lived off the land. Those kids were able to go to school, whereas in the highly intensified plantations, the people were just cheap laborers. Yep. And I was then offered a PhD position, but I couldn't help but think that we never actually gave anything back to the people there. And we kept the knowledge to ourselves and got our degrees and titles and wrote the papers. And I kind of felt like that's not my kind of scene. And so I decided to start looking for a job in the real world. And I have become very interested in fair trade through this experience in Tanzania and in agriculture, organic agriculture. So I started as a research assistant or researcher at the Research Center for Organic Agriculture in Frankfurt. It's called FIBE. And I did a trainee program in organic value chain management, this trainee program Ökolandbau. In my 3 years at FIBO, I worked in a diverse range of projects. I've just brought a few examples for you. For instance, we looked at the ecosystem services of legume plants, such as beans, lupins, and maybe you've seen this lupin yogurt, vegan lupin yogurt. Yeah, stuff like this. Then we worked on a project that I found very fancy. It's called Watermark or Wasserzeichen, and we used stable isotopes to trace the regional origin of crops, like wheat and spelt and so on, to avoid fraud in organic agriculture. Because it makes sense when you can get so much more money for a load of wheat to, if you declare it as organic, to try. But with this Watermark project, we tried to avoid this fraud in the organic sector. And we also have very interesting international projects. My favorite one is in the center when a sheikh from Abu Dhabi called the CEO in Switzerland and said that they want to have organic agriculture in Abu Dhabi in the desert. And everyone's like, okay. I think the biggest challenge there was to create organic matter because there's only sand, right? You don't have a humus layer or anything. Yeah, and projects like this are very interesting if you think about a desertifying planet. So yeah, cool experience. And I helped organize an annual conference. So I picked out a few of my favorite projects. And this conference was for young organic farmers. And they could network and party a bit and yeah, just meet experts from the organic sector. And the cool thing was that often you have a farmer, an old farmer that doesn't have their kids don't want to take over the farm. But then you have young farmers that are not born into a farmer's family. And if you bring these two together, then you can maybe enable passing on the farm into the next generation. Those were a few cool side projects that I had, but my main job at FIBO was on a project that was part of the UN Decade for Biodiversity. And it's called Kindergarten im Kindergarten. And you can see in this map in the right corner, these little red dots. These are about 200 institutions across Germany that participated. And my job was to build and maintain this network between the kindergartens and to organize, hold workshops in the institutions. And these workshops were usually on biodiversity related topics like gardening, organic gardening, building raised beds, making deadwood beds, permaculture, everything around how to teach kids about biodiversity and sustainability with your own garden. And we taught the primary teachers. So here's a picture on the bottom right of primary teachers, Kindergärtnerin, Erzieherin, sagt man heute, how they're drilling holes in the wood, and that's for wild bees. Yeah. And then the teachers, I think it was cool because the teachers passed it on to the kids and the kids to their parents and so on. Yeah, and through this job, I got many requests to do workshops with kids directly. And this is my favorite example for one of them. It's a collaboration between a high-risk school in Frankfurt next to the main train station and a farm outside the city. And these children had a lot of pent-up energy and aggression, I have to say. And when we arrived on the farm, they completely changed. Like, I've never seen such a drastic change in a person. And they suddenly, when they planted salads, they actually like held them as if they were little baby birds that had fallen from the nest. And they walked super calmly next to the horse, to the farm horse, and they cared for one another when we made lunch. So yeah, it was super cool to see what a bit of land and trust from the right people could do for these children. That's the Fiebel office in Frankfurt in the city center. And we had a beautiful rooftop garden, and I had just taken a course in beekeeping. So my colleagues got a small swarm for us, and one fine day I came down and a bunch of wasps had was attacking the colony, and half the bees were dead. So that was super horrible. Wow, okay. Attack. So for those people on Zoom, there's a red light turning on, and I don't know what it means. Okay. Okay, so half the colony was dead of my bees, and it was wasps. That was horrible. But it also made me think differently about how we breed animals. That we breed honeybees so that they are so tame that we can manage them, but then they are too tame to defend themselves. That didn't really make sense to me. And I thought bees were cool back then, but I know that sounds kind of cruel, given the circumstance that they were just murdered. But then I kind of felt like wasps are maybe cooler. Yeah. And luckily, I got a PhD scholarship to study wasps that took me to some of the most pristine places in the world on those New Zealand's offshore islands. And in the center of the photo, you can see Little Barrier Island, which has some of the last breeding populations of kokako birds and kakapo birds, and tuatara lizards and giant wita, and all species that you might have seen in a documentary about New Zealand. So they're all highly threatened and endemic to New Zealand. So these islands are really last refuges for one of the last species, or one of the last species on this planet. Their islands are also model ecosystems to explore ecological questions. And I was encouraged to incorporate some interactiveness into this talk. So here we go. For those who don't have to drive tonight, feel free to drink whenever I say the word wasp from now on. Good luck. Social wasps are invasive in New Zealand, and they cause like a lot of ecological and economic damage by depleting carbohydrate resources. And carbohydrates could come from nectar or from honeydew in the trees, you know, the scale insects that suck the plant juice and then they excrete like a sugary drop. That's what honey, forest honey is made of. And wasps go crazy for that. And New Zealand has got some very abundant resources of this honeydew. They also feed on native arthropods, like in this video. Can I start this? Yeah. This is Pholistis chinensis, so the Asian paper wasp attacking a monarch butterfly. And they usually feed on the larvae, on the caterpillars. But in this case, it seemed to be very hungry. So yeah. They also attack stick insects, like these beautiful, you know, stick insects, and spiders, endemic butterflies, and so on. And because the winters in New Zealand are a lot milder compared to the European native range, they can overwinter there and build giant nests like this one here that was found in the Waitakere ranges close to Auckland, and it's 2.5 meters by 2 meters by a meter in size. And it's got probably about at least a million individuals living in there. Yeah, imagine going for a walk and stepping on that. Or imagine being a stick insect. Like in this forest, you probably won't survive the day. So we knew that this was all going on the mainland of New Zealand, but no one had actually looked into the presence, or let alone the abundance, of these wasps on offshore islands. And as I just said, those are the last refuges for many species. So I packed my wasp suit and seasickness pills and went to 36 islands in 3 months. It was a very busy time. And in this photo, you see my supervisor on the right, Jacqueline Biggs from New Zealand. And some of these islands were 30 minutes by ferry, and some of them were actually 3 hours away from the mainland, and I had to row ashore in some little dinghy. And I had never rowed in a dinghy before, and I rowed in a circle for half an hour until I got it. Yeah, and some had livestock and people on them, and some of the islands really hadn't seen a human for 2 years. And like this one on the right photo, where we had to climb up this molding rope and no one knew how old the rope was. It was probably the dodgiest thing I've ever done in my life. Yeah, I brought you some summary photos to give you an impression of New Zealand. And back then I made a stop motion video, which is a little bit crappy, but also a bit entertaining. Also, I'm going to show it to you because then I can maybe have some beer too in the meantime. Okay. I think you have to play it now. I can? Ah, hold on. Oh, it's with sound, sorry. Mm-hmm. I can, yeah, this, I mean, it's not professional at all, but it was good to get the message across because, yeah, I could actually give the results to people who usually wouldn't read the full paper. And yeah, I put a lot of effort into science communication of the results and wrote multiple press releases and gave radio interviews and wrote articles for magazines. That was, yeah, it was important to me because I wanted to get the results out there and wanted them to be implemented and actually do something for the environment. And it was cool that Auckland Council then uses this method that I'm going to present as a standard method for wasp monitoring on the mainland and the islands. And they also used the paper that I published in Diversity and Distributions in 2019 as a reference for island management decisions. And my hope, oh, I can't say that before, okay. My hope I'm going to tell you later. Goodbye. Darf ich ganz schnell einen Radler nehmen?
Ja klar, ich kann es auch.
Echt? Okay, ich habe nämlich nur 3 Minuten mit so einem kleinen Film, aber passt. Danke, danke, danke.
Julia from the University of Auckland. In your last video blog, I introduced you to my PhD topic, invasive social wasps on New Zealand's offshore islands. This time, I'd like to take you on a trip to these unique islands, and together we're going to investigate the question, what drives wasp abundances on offshore islands? You ready? Okay, let's go. We've got 36 islands to see. We measure wasp abundance using 5-minute wasp counts at 10 different sites on the island. Yeah, we just borrow this method from bird people. Then we collate data on canopy cover, native and exotic vegetation, and human settlement in suggests a link between mammal eradications and the disappearance of wasps on 3 islands, Tihauturu-Otoi, Tiritiri-Matangi and Korapuki Island. Okay, let's see if we can prove this. Yes, there are no vespular wasps on the 3 islands, but hey, there are paper wasps on 92% of the islands. What we want to find out is what drives wasp abundances. So let's run a GLMM with the factors we collided and select the best model to find out which factors are correlated with wasp counts. Okay, so here are the results. These are the factors that significantly correlate with vespular count. Island isolation, which is distance to the mainland, canopy cover in percent, and recent human settlement. That means that far away islands that have high percentages of canopy cover and are uninhabited have less wasps, while close by, inhabited islands with little canopy cover have high vespular count. Polistes abundance correlates with canopy cover only. The higher the levels of canopy cover, the lower the wasp counts. This is not surprising, as Polistes as well as vespular wasps are adapted to open grass and pasture land. Surprising is that in contrast to our hypothesis, we found no correlation between mammal presence and wasp abundance. But there is one factor that is particularly interesting, as invasive species are often regarded as the villain of the virgin ecosystem. Our results show that human settlement is the major biotic driver of invasive vespular wasps on islands. I leave it to you to decide about the villain of the story, but I personally think that science doesn't need villains. Let's try and understand causes and consequences instead. It's time to leave the islands and fly back to the mainland. I hope you enjoyed the trip. Thanks to you and many others for supporting my research.
Okay, so what I found with this study is that intact forest cover can keep away invasive wasps, right? And yeah, my hope is also that if there's human settlement and farming on islands, that really increases the chances that they are swarmed by invasive wasps, and that's not a good thing. And other studies found similar results for mammals, and they're also invasive in New Zealand and destroy a lot of seabird populations. So keeping the forest cover intact and maybe keeping the human settlement and the farming off those islands would be one hope that I have that we achieved with this science, because some of the islands are really unique and yeah, they were being sold out to foreign investors. And I think it's just a few places in the world that are so pristine and we should keep them. And personally, seeing these results being somewhat implemented was probably, the most rewarding thing for me in my career. Oh, damn it, how do I get? Okay. So now that I had found invasive wasps on 35 of 36 offshore islands, that's a lot, right? I wanted to find out more about their ecological impact on the island fauna. And here's a question to the audience for interactiveness. What would you look at if you wanted to find out what impact an invasive species has? Any ideas?
At the local species.
Mm-hmm.
If you have any data, then you see the impact of the invasive species.
Mm-hmm. And what would be a very direct effect of the invasive species on the local? What could they do to them? Mm-hmm. Yeah, they would eat them, right? So the diet, I looked at the diet of these wasps, because then you know what they've been feeding on, and yeah, that's a very direct measurement of their impact. So I wanted to know whether they were eating mostly natives and endemics on these islands, And I wanted to know whether the diet would differ between the 4 invasive species. So in the bottom left, you see Vespula germanica, it's a German wasp, and Vespula vulgaris, the common wasp. And those 2 are from here, so from Europe in general. And then in the bottom left, you see Polistes humulus, the Australian paper wasp, and right, you see Polistes chinensis, the Asian paper wasp. So I went back to this beautiful privately owned island called Great Mercury, or Oahu, because they had all 4 species there. And a little side story, these are the white cliffs of Oahu, and they were the first thing that the Maori people, the first settlers of New Zealand, saw when they approached New Zealand in their wakas and their boats. And together with my colleague and now fiance, we collected and dug out 64 nests on this island. And here's one of them. It's a common wasp nest. And you can see these beautiful layers. And yeah, this one here is a paper wasp nest. And the dark bits, you can see them. That's the gold we were digging for. These are fecal samples of the wasp larvae. And these larvae, they hang in these cells like head down and feet up. And so they defecate into their cells against gravity. I think it's pretty cool. Anyway, I extracted the DNA from these fecal samples and yeah, looked at the diet, or the insect DNA in these fecal samples is collected over a whole season. So usually when you collect data on diet, you go to the nest and you catch a forager and look at the prey item they have. And then if you're lucky, you're able to identify, oh, it's a chewed up caterpillar, or it's a bug or something. But that's a very specific snapshot of time. And with this method, you basically have a cover of all the insects that were eaten over a whole season. And these are the results from the metabar coding. We see the bar graphs of the diet composition. And again, on the left, bottom left, top left, the German wasp, and next to it, the common wasp, and then the Asian paper wasp and the Australian paper wasp. On the x-axis, you see the different orders of prey, and the y-axis, you see their percentage of the total diet. And we can see that the Lepidoptera bar, so all 4 species fed mostly on Lepidoptera, so on butterflies and moths, right? But interestingly, the overall diet of the 4 species, even though they had this shared resource, Lepidoptera, was quite different. So they didn't really eat the same stuff. And you can see this in the little bars next to the Lepidoptera bar, that they fed on pretty different groups of insects. And also the Lepidoptera itself, they shared only a few families, and mostly were totally specialized on different families within Lepidoptera. And that means that they didn't really compete, and that's bad for invasive species. So they basically have their part and live well on this island, so they have a bigger ecological impact because that there's no competition for them. In the pie charts, they show the percentages of prey that were endemic, native, and exotic. And yeah, this blue color stands for endemic. So you can see that the Vespula vulgaris is the worst guy when it comes to endemic species that feed on. Then native is depicted in like purpley gray, and exotic species are this reddish color. And if you want to see more nice figures and read up about the method, you can find it in the Journal of Applied Ecology. It was published early this year. But this one here was the New Zealand context, right? So where they were bad, we knew that. But if you look at these results in a different context, wasps could actually be very good and useful, because moths and butterflies, flies and bugs are the farmer's worst friend, we can say that, typical pest insects in agriculture. So while I thought in the introduced range, they're obviously harmful, but in the native range, they might actually be heroes. For instance, in an urban gardening context. So I started my job, as Monica said, in May, here at the Urban Productive Ecosystems Chair. And it's been a very busy and super fun fieldwork season. And we're doing research in 30 gardens in Berlin and Munich. In this photo, you see the Südgarten in Munich. It's a small garden surrounded by a lot of concrete and by train tracks. And yeah, it's a cool garden you should visit. There's a lot of lizards rummaging around. And to make the connection to the beginning of my talk, yeah, I think it's not just in Africa where you have to hide away from the sun, but it's also in our densely populated cities that an acre of land can be like an important refuge for plant life, for insect life, and for people. So among many other fascinating studies that we're doing at UP Lab, my new research question is, can social wasps be utilized as natural pest control agents in urban agriculture? And at the moment, we are collecting nests. I went to Berlin last week and we'll pick up some more nests on Friday in Munich. So if you have any nests sitting around at home, they are welcome in our freezers. And yeah, stay tuned for updates on this research sometime soon. So to come back to the title of the talk, The Good, the Bad, and the Ugly. Insects in agriculture. Yeah, I think the good is pretty clear. It's usually honeybees or bees in general. Then we have the bad. I just put this caterpillar there because I don't know, but you have a right to say no to this if you have a good study showing that caterpillars are really good for crops. And the ugly, I mean, there are people that actually think wasps are not cool, but yeah, I think there's a lot of potential and that they provide a very important ecosystem service, and I'm keen to keep working on them. And I think that their potential in agriculture is heavily overlooked. Yeah, and obviously this research would not have been possible without the help of a lot of people and funding institutions that supported me over the years. And I'm just going to say a collective thank you to them, and of course to all of you for being here.